Well, hi everyone. I hope you had a good lunch break. We're back. Our next talk will be from Sandeep, Puvantheetil, Satheesan, who is a senior research software engineer at NCSA, and he will tell us about AI support in Clowder.
Good afternoon, everyone. Welcome to this next presentation as part of Clowder All Paws. And Luigi, thanks for the introduction. So we'll get started right away. This is the a brief introduction and outline for the session. So we'll start with some little bit of introduction and a brief background on supervised learning. We'll look at the current support for training machine learning and deep learning algorithms in Clowder, as well as like how to run them using Clowder. And we'll also look at some example extractors that we currently have that run using machine learning, deep learning models. We'll also look at some previous use cases based on computer vision and image analysis. We'll conclude and then we'll have leave some time for Q&A at the end. So I think the titles can be a little bit misleading. I mean, when we say AI, actually there is a difference between AI, machine learning, and deep learning, and I think many of you, if not most of you, would be already aware of that. So when we say here when we say AI, we are actually referring to AI as a broader or a term that is more commonly used these days. But when we come to the specifics, I guess like we are talking about the current support for some of these specific AI technologies within Clowder, which are the capability to like store training data sets and manage labels as metadata, and then use that training data set for supervised learning external to Clowder. And also like then how you can use those trained machine learning models as information extractors within Clowder. So let's maybe spend a few minutes on supervised learning. Again, I know that many of you might be already aware of this or would have heard about this as an approach within machine learning, but this is just to set context for this session without going to a lot of details. So supervised learning is a subcategory of machine learning and artificial intelligence. Here, the main idea is that you have these data sets, large data sets, which have labels or annotations that is used for either like classifying data, the problem is for classification, or to predict outcomes, which is regression. So here, the training data set basically refers to the collection of input data plus correct outputs, or it is also known as ground truth. The model basically learns using these training data set. It measures accuracy using specific loss functions that are pre-decided. It also, during this process, basically it looks at examples and adjusts its weight internally to improve itself, and also like continue the training until the error is minimized. So you can see that pretty much that workflow on the diagram on the right hand side, where these label observations are like divided into two sets, the training and the test set. The learner uses the training set to adjust its weight, and then it evaluates itself in the test set, which is it has not seen before, and then that's where we have what we call as a machine learning model or a prediction model, which also like provides some stats about like how accurate that model is. Obviously, like there are like very well-known examples like object detection, object recognition, object segmentation, span detection, etc., as part of the supervised learning approach. So that's just a little bit background on supervised learning, and let's now look at what we have currently in Clowder. So the first thing is, when we talked about supervised learning, we need, we mentioned about the training data sets, right? So the first support is for, to train machine learning and deep learning models. And when we say that currently we can use Clowder to store training data set. You can generate these labels either through an external process outside, or it can be even done using information extractors. And then these labels can be attached as metadata to this data set. The good thing is that you can also update these labels as the metadata can be updated in Clowder. So if for example, if there is like an automated process using which you generate some training data, then which then there is, and then when people have to come in and make some changes or fix some errors, that is possible through Clowder. You see this, GitHub URL. This is an example extractor that we have. In that, there are also some examples for downloading all of these files in a data set with a specific label as Clowder metadata. There are examples for creating a TensorFlow data set. And then also uploading the model file, which is usually of the HDF5 file format, and how to upload that model back to Clowder with some information about which specific version of TensorFlow was used, who was the author, and the weights. The actual training itself happens outside of Clowder in dedicated resources because machine learning training is very compute intensive. So that is not currently supported within the Clowder framework, but it can happen anywhere in any of the dedicated resources. For example, when you have all these GPU clusters or even cloud. So once you have the the trained model, now the next part is how do you run these models as extractors? So here we have provided an example image-based TensorFlow extractor where so you have already trained this model external to Clowder, in a dedicated resource. You already have the model. Now using the TensorFlow extractor, you can load the model, the machine learning model or the TensorFlow model and the classes. And once you start the extractor, basically the extractor connects itself to a Clowder instance. And say, for example, when you upload some images to that particular Clowder instance, those images get picked up by this TensorFlow extractor, which runs this model, does the prediction, finds which classes that particular image has, or segmentation, which does the segmentation, and then uploads this metadata back into Clowder, and then which you can view within the Clowder web front end. So the obvious question to ask, is can we dynamically load these models? So for example, you have some model, can you just upload the model and then say that, okay, for this particular data set, we need to have this particular model, machine learning model process the data. Yes, it is possible, but I guess we'll have to make some changes to the current approach. There is an architecture diagram in here where we envision the use of loading this model dynamically within a Dockerized extractor that can then process the metadata. So for that, I think we have to make some changes to the existing extractors where you can supply the model and classes as parameters. So for example, when you're setting up an instance of Clowder and you're saying that, okay, you need to have the TensorFlow extractor, you can also say that, this is the model, these are the classes, and now, at that point, it would be set up as to run these models dynamically. So that's something that's a future work. So basically, these are the at a high level, this is the current support for AI technologies within Clowder. So let's maybe look at some example machine learning, deep learning extractors that we have. So we look at 3 examples. The first is the Fashion MNIST TensorFlow extractor. So this uses the Fashion MNIST dataset, which is a dataset consisting of article images belonging to 10 different classes, which has about 60,000 training images in the training data set, as well as 10,000 images in the test data set. So you can see the example, like a screenshot from Clowder here, where there is a data set in which we have uploaded some images. Once you go into the images file, you can actually see the metadata. So in this case, the model correctly predicted this particular image to be a coat. This is also like a case where this particular model has failed. So, and this particular extractor is in the Clowder TensorFlow repository within GitHub. And this is also basically based on the popular tutorial mentioned here. The next one is the SMU City of Dallas sidewalk detection. I guess earlier today, Dr. Barbara Minsker had mentioned about this use case. So for that use case, this extractor was developed which was trained on the SMU mainframe GPU cluster. It used the cityscapes data set, which has about 25,000 annotated images from 550 different cities. And you can see some example images from based on processing in that data set. So you can see the sidewalk detection as well as the shadow removal that was done as part of this extractor. Currently, we are looking at looking at the process of handling labels for paths which are made up of like multiple sequence of images. So you have a sequence of image and then how to label paths for that sequence of image instead of a single image. These are some screenshots from Clowder. Again, you can see the so it might not be very clear. There is a small difference in color. So the rest of the images are like grayed out, and the sidewalks are detected here. And obviously, you can see the sidewalk is blocked. Even here on the right hand side. The next extractor is the mask RCN extractor. That is also something that we currently have within the Clowder suite of extractors. So this is a popular deep learning model for instance segmentation. So for those who have not heard about instance segmentation, the idea is that you detect an object, you also detect the individual objects, and then also detect the regions that object belong to, so that you can now differentiate between this car and a second car, and also you can identify which pixels belong to this car and what is in the background. So here you can see the extractor processing some example images. I think this particular extractor would have been trained on the MS COCO dataset. If I'm wrong, please correct me. So you can see the images of different animals. Again, like it might not be very obvious. I think it also like detects which animal it is as well as the pixel regions. Similarly, like a person, snowboard, the second person here, another person here, and so on and so forth. Now that we looked at the some example machine learning deep learning extractors, let's look at some computer vision image analysis use cases from some of the previous projects that we have had here, or that have used Clowder. So the first one is the video analysis tableau. So here the goal of the project was to attempt basically to fuse software, arts, and humanities. So a bunch of extractors were developed as part of this project. Mostly focusing on the video data. So in here you can see like once a video file gets uploaded, these different extractors run. For example, this is a shot detection extractor that identifies different shots. Then some feature descriptors were extracted from these individual shots, which were then used for identifying similar shots. So given one shot, how do you find the other shots that are similar based on these different feature descriptors? The other thing is, there was another extractor which worked on this movie slice visualization, and there was also like a previewer that was. And movie slice is something where you put all these frames like one behind the other, and then what happens if you take a slice across? It forms some sort of like a unique identification for the video. The next use case is from a different project called the image analysis of rural photography. Here, the goal was to analyze these photographs, black and white photographs from the Depression era. And we processed about like 176,000 photographs from this. Again, here also, like we had a bunch of extractors that would process image data as well as image metadata from this collection. And, when this particular extract, when you upload an image, you can see here a bunch of extractors extracted information. We also had some person detection, face detection extractors, OCR that were combined together for this particular use case. And then there were also like extractors that would look at grayscale values, striker punch. That was like that's a hole that was put in these images. I think it was done by the editor of those images to mark those images as like not ready to be published. The final use case that I'll be talking about today is the Bertillon card analysis extractor. Here, the goal was to recognize handwritten text and decimal numbers from scanned Bertillon cards. So Bertillon cards are basically like prisoner identification cards, which had like people measurements, information about the person, prison number. A lot of details were there. So the goal of this extractor was to extract data. So as you can see here, like look at this tabular data, segment into individual columns and rows, get to the individual digits, and then finally like combine all of these together as like decimal numbers, and then attach all this back as like metadata, back into Clowder itself. So to conclude, I think we basically discussed about the current AI technologies that are supported by Clowder. Specifically, we looked at how Clowder supports storing the training data set, downloading of the training data set, and then using that training data set, obviously outside of Clowder for actual training purposes. But then you can then bring that model back, and then it can be combined. It can be put as an information extractor that works, that connects to Clowder, and then process the data. We also discussed a little bit about like the improvements that are needed to dynamically load models from Clowder and run any machine learning model as an information extractor. We also, I think, we briefly looked at some example machine learning extractors, as well as some computer vision use cases from the past. I think that concludes the slides, and these are some of the references that I used. Obviously, I need to mention that all these projects were done as part of like different collaborations throughout the US. And I think there were like multiple funding agencies involved. So there is no like specific acknowledgements, but just to mention that it is a part of a large different sets of collaboration that we have, that has used Clowder. All right. Thank you for listening.